In the circuit below, the battery has negligible internal resistance. Three identical lamps L, M, and N of constant resistance are connected as shown. The filament of lamp N breaks. Which of the following shows the subsequent changes to the brightness of lamps L and M? First of all, brightness depends on power. The greater power is, the greater brightness is. And we know the next formula for power. It's current times voltage, voltage squared over resistance, or current squared multiplied by the resistance. And you can see that there are three lamps of constant resistance. It's very important. And if you know how voltage across some lamp changes, you may conclude about power and then about brightness. And it's only enough to know how voltage changes, and we use this formula. Or it's enough to know how current only changes and use this formula, because resistance is constant. But if you use this formula, you need to know how product of current and voltage changes. It's not enough if you know that voltage increases. You cannot conclude that power increases, because there is another variable, it's current. Let resistance of every lamp be 1 ohm. And initially, when N works, total resistance across A and B is 0.5 ohms. How to get this? For parallel, we use the next formula. 1 over R total is 1 over R1 plus 1 over R2. But if components are equal, I mean when components have same resistances, you can find the total or the resultant resistance as you take resistance of 1, it's 1 ohm, and divide by the number of components. So it's just 1 divided by 2. But it works only if resistances are the same. So, and actually, what does total resistance mean? It means that we can consider these two lamps as one component of which has a resistance of 0.5 ohms, and another lamp and with resistance of 1 ohm. And we know that two components in series divides total voltage, let it be 3 volts, proportionally to their resistances. And you can see ratio is 0.5 to 1, or to get integers it becomes 1 to 2. So they divide total voltage in ratio 1 to 2. How to divide 3 volts in ratio 1 to 2? There are 3 parts in total. 3 volts divided by 3. So it's 1 volt per 1 part. So 1 volt here, 2 times 1, 2 volts here. Or 1 over 3 of 3 volts for this component, and 2/3 times 3 volt for this component. Or you may, another way, you may find total resistance in series. It's the sum, so total resistance is 1.5, total voltage 3 volts divided by total resistance. You can find current. It's what, 2 amps, and current in series is the same. And using the formula, voltage is current times resistance. 2 times 0.5, we get 1 volt across this, and 2 times 1, 2 volts across this. And now when N breaks, you can see that ratio becomes 1 ohm and 1 ohm, and now they divide 3 volts in ratio 1 to 1, and it's clear that it becomes 1.5 volts and 1.5 volts. And you can see that voltage of what? Of L increases, and voltage of M decreases, and hence power does the same. So power of L increases, hence brightness increases, and power of m decreases, so brightness of m also decreases. And how to get this result quickly? You don't need to do such calculations. You should understand that always parallel junction minimizes total resistance. In series, it's always maximizes total resistance. And you should understand that when M breaks, resistance across AB increases. And since components in series divide total voltage proportionally to their resistances, and now L gets the greater share of total voltage. So voltage across L increases, but since they are in series, total voltage is constant. It's voltage provided by the battery or e.m.f. So if voltage across L increases but sum is constant, hence voltage across M decreases. So C is correct. The next. In the circuit below, the voltmeter has a resistance 100 kilo ohms. The battery has negligible internal resistance and e.m.f 6 volts. The reading of the voltmeter. We know that the ideal voltmeter has infinitely large resistance, but since it has some resistance which is not infinitely large, we should just take into account its resistance as resistance of some additional component. And again, we can find total resistance across AB, and you may use formula 1 over total is 1 over 100 plus 1 over 100, but if components are equal, you just divide by 2, so total resistance is 50. And now it looks like two components in series with resistances 50 and 100, and we know that components in series divide total voltage proportional to their resistances. So these two components, notice that we consider as one component across AB. They divide 6 volts in ratio. What ratio? 1 to 2. Total 3 parts, 2 volts for one part. So there will be 2 volts across AB, 2 volts, and the remaining 4 volts across this component. And we know that potential difference of voltage in parallel is the same, or actually potential difference voltage across voltmeter is 2 volts, or voltmeter measures potential difference between 2 points A and B, and it's 2 volts, so it's B, 2 volts. Or you may find you find 50 and then find total resistance 150, 6 volts divided by 150. You can find what? Current, but notice that it will be current, and we know that current is the same in a series, so it will be current through the battery and up to point B, up to this parallel junction. And it's clear here that current through each branch in parallel, it will be a half, because same resistances. But in general, you should apply what voltage in parallel is the same, so you equate voltage, current, resistance for one branch and for another. But if you know current, its current will be through this. Then you can calculate voltage as current times resistance, so this current multiplied by this resistance and find voltage across this. Then 6 minus this result, you find voltage across AB because they are in series. Let me calculate to be more clear. 6 divided by 150, it's 0.04. So its current 0.04, it's here. And this 0.04 is equal to the sum current through this and current through this. For this particular problem, it's clear that it will be 0.2, 0.2, but it's because equal resistances. But in general, it's not true. And we can find voltage across this as 0.04 times 100. It's what? It's just 4 volts. So 4 volts across this. Hence, across AB, voltage is 2 volts. The same result. The next. In the circuit shown below, the cell has negligible internal resistance. Which of the following equations is correct? So you can see the cell and what again? AB, and these two components, two resistors, are in parallel. And current through the cell up to this point, I1, is equal to the sum of currents I2 plus I3. It's true, but there is no such an option. And since AB, these two branches, two components are in parallel, and we know that voltage in parallel is the same, and we know that voltage is what? Current times resistance. So current times resistance for this, so current I2 times resistance, it's just R, is equal to, so current resistance is constant for parallel, is equal to what? I3 times 2R. R cancels and we get that I2 is 2I3. And that's all for this question.